Science in Pajamas. Alright, guys, welcome back. Today we are going to be looking at some examples of free fall and in terms of how to solve for them. So we're going to be using the equation and solving for free fall. Now remember, free fall is when an object is in motion due only to gravity. So here I have my little push ball. If I bring it up here, it's at rest. I let go of it and it falls. While it falls, it is in what's called free fall, because as soon as my hand lets go of it, the only force acting on it is gravity. Now gravity, nice thing about it is it has a more or less constant acceleration of negative 9.8 meters per second squared. And we say negative acceleration, negative 9.8, because which way is gravity pulling the ball? It's pulling it down. Alright guys, so let's take a look at some examples and some equations. Some examples and solve them using what we know about acceleration. Alright, great. Here's our first problem, our first free fall problem. A rock drops off a ledge. How fast is it going after 10 seconds? Alright, so what do we know? At first glance, it does not look like we know a lot. We know the time. Let's see, 10 seconds. How fast is it going after 10 seconds? That means that we are looking for our final velocity. But what about these other two terms? Well, it drops off a ledge. That means that there is no propulsion behind it. That means the only thing acting on it is gravity. It's a free fall problem. So that automatically tells us that we have to use the acceleration due to gravity, negative 9.8 meters per second squared. Yeah. All the free fall equations, all of them, the acceleration is going to be due to gravity, so that's negative 9.8 meters per second squared. Sorry. All right, and what about the initial velocity? Well, it was just sitting on the ledge. It wasn't moving. It was just sitting on a ledge. That means it's at rest. And if it's at rest, that means that it has zero initial velocity. All righty, so let's go ahead and get solving, shall we? I'll put our problem up here. We know from our equations, acceleration equals Vf minus Vi over delta t. I'm just going to have to go ahead and just plug that in. So acceleration, before I plug it in, we're looking for Vf. So I'm going to rearrange this first to get that by itself. So we're going to go multiply both sides by time to get it out from under the fraction. We're left with acceleration times time equals Vf minus Vi. Alright, again I want Vf by itself, so I'm going to add Vi to both sides. Cancel it out there. And we're left with Vf equals Vi plus A times delta t. However, remember, our initial velocity is 0. So 0 meters per second plus the acceleration, which is negative 9.8 meters per second squared, times our time, which is 10 seconds. All right. When we look at that, we can actually, since this is 0, we can kind of disregard that, and we're just going to be multiplying these two together. So the final velocity equals negative 98 meters per second. Negative, once again, it just means a direction. It is moving downward. So since it's moving downward, it has a negative velocity or in other words, 98 meters per second downward. That's all that the negative sign means. Not horrible? I hope not. All right, move this out of the way. And let's look at a couple more. So a flower pot falls from a windowsill that is 65 meters above the ground. How fast is it moving when it hits the ground? So once again, let's take a look at what we have. How fast is it moving when it hits the ground? That's going to be our final velocity. It was sitting on the windowsill. That means its initial velocity was 0 because it was just kind of hanging out. It was at rest. It's a free fall problem. I know negative 9.8 meters per second squared is my acceleration. And I know how far it fell. It fell 65 meters. Now, obviously, as you can tell, we can't use the standard equation for this one. We cannot use the A equals VF minus VI over delta T because we don't have time. Instead, we have the displacement. But we did recently solve in one of our videos, we solved for final velocity related to constant acceleration. And that equation, VF equals square root of VI squared plus 2A delta T. No, I'm sorry, delta X. So we actually solved for that equation in a previous video. Okay. What we would do now is, first of all, initial velocity is 0, so we can just disregard that. You can just plug it in now. VF equals square root of 2A delta X equals, sorry. Once again, I'm rearranging, make it a little more comfortable for me. So square root of 2 times negative 9.8 meters per second squared. Now, most calculators are probably going to give you an error message for putting the negative sign underneath the square root sign. So for the calculation, for the actual putting it into the calculator part, you might want to leave that out. Times, what was it? Oh yeah, 65. That was our distance. And when we go through and we do that, we know that the value would be 35.7 meters per second downward. So you can also think of that as bringing that negative that we took out just because of the calculator and putting it back in. And if you don't like that, then just include the downward so we know our direction. So that's all a negative sign is, it's just direction. So it's experiencing a velocity of 35.7 meters per second downward when it hits the sidewalk. All right, let's take this question and go one step farther, shall we? So we solved for that. The final velocity was 35.7 meters per second. So we know that. I'm going to leave those values there because we're going to continue on with this problem. How much time does a person have to move out of the way? So they see that the flower pot is falling from the windowsill, it's going to hit them. How much time do they have to actually get out of the way? Well, what do we know? Well, if we're looking for time, then that means we don't know it. But we know the rest of these. Again, free fall, so it's negative 9.8 meters per second squared for the acceleration. It started out as rest, so 0 meters per second for the initial velocity. And we just calculated this. Negative 35.7 meters per second. Now all we gotta do is take the good old acceleration equation and rearrange it to solve for time. So A equals VF minus VI over delta T. Multiply both sides by T, get it out from underneath the fraction. We have A delta T equals VF minus VI. Again, we want to solve for T, so we got to get rid of the A, move it to the other side by dividing both sides by it. And we are left with delta T equals VF minus VI over A. We know all these values. We calculated the VF already, that's negative 35.7 meters per second. The initial is 0, so negative 35.7 or minus 0 is just negative 35.7. And the acceleration is negative 9.8 meters per second squared. So since negative 35.7 minus 0 is just negative 35.7, I'm going to take that out. And we have two negative signs, which will cancel out to become positive. And the time, once we do our math, would be 3.6 seconds to get out of the way of the flower pot. All right, so I kind of hope that helps you out a little bit, hopefully with these free fall problems. In the meantime, you guys, if you have any questions, don't forget, hit me up in Google Classroom, through email, or in our actual classroom. But in the meantime, just stay awesome, stay amazing, and stay safe and healthy. All right, you guys, take care. Bye-bye. Oopsies.